The basal ganglia are a group of structures that are generally considered to include the caudate and putamen, which are collectively known as the striatum, the globus pallidus, subthalamic nucleus, and substantia nigra. The globus pallidus is further divided into internal and external segments, and the substantia nigra is divided into the substantia nigra pars compacta and substantia nigra pars reticulata. The direct pathway is a circuit in the basal ganglia, best known for its hypothesized role in movement. The direct pathway model involves glutamate neurons that project from the thalamus to motor regions of the cerebral cortex. These excitatory projections are thought to be involved with stimulating movement. Neurons from the globus pallidus internal and substantia nigra pars reticulata, however, project to the thalamus and maintain a steady release of the neurotransmitter GABA, which acts to inhibit the thalamic neurons and suppress movement. This mechanism is thought to be important in keeping unwanted movements from occurring. When we want to make a movement, however, information about the movement is sent from the cortex to the striatum via the corticostriatal pathway. Glutamate neurons in this pathway excite neurons in the striatum, and the activated striatal neurons release GABA in the globus pallidus internal and substantia nigra pars reticulata, inhibiting the activity of these regions and stopping the inhibition of neurons in the thalamus that are involved with movement. This effectively opens a gate for movement to occur. Activity along this pathway tends to occur just prior to a movement, and thus has been linked to the facilitation of movement. The substantia nigra pars compacta is thought to modulate the activity of the direct pathway. Neurons from the substantia nigra pars compacta travel to the striatum via the nigrostriatal pathway and release dopamine in the striatum. One effect of this seems to be the facilitation of activity in the direct pathway.